Hello, this is how to develop KDE software inside the Linux operating system KDE Linux. On Google I searched for KDE Wiki, KDE Linux, KDE Builder. So this is Wiki, as in Wikipedia. This is an operating system, and inside this operating system KDE Linux I'm going to use KDE-builder. And this is the correct result, building KDE software with KDE Builder. And KDE Linux develop KDE software. First of all, we're going to need a installation of the operating system KDE Linux. We're going to use a virtual machine, Virt Manager, QEMU, KVM. I'm on a Linux operating system. Thank you for subscribing and helping this YouTube channel. On Google I search for KDE Linux. It takes me to the correct web page, kde.org/linux. We're going to need the downloads. So install KDE Linux. We're going to use a virtual machine, Virt Manager. We're going to use UEFI without secure boot. These are the installation instructions. Therefore, if you want to install KDE Linux on a hardware computer or laptop, I'm going to use a virtual machine. Let's see how the installation instructions are different for virtual machines. It says that to install KDE Linux in a virtual machine, follow the advanced instructions here. Download the latest raw image. There are quite some hoops to get to the probably short installation instructions for virtual machines. Okay, what am I supposed to download here? A raw file, the newest one. So file with extension raw, 6.5 gigabytes, and the newest one. Hopefully the list is sorted descending by last modified, which it seems to be. So we're going for this file. It seems that we're going to download a Panasonic raw image, which we're not. Okay, so the raw file has finished downloading. Now we're on this wiki page, community.kde.org/kde-linux installing on a virtual machine. It says that we have downloaded a raw file, and when we create virtual machines, we usually use .iso files. So there might be a different way of installing this type of Linux operating system, KDE Linux. And there's instructions for different types of virtualization software. These are for Oracle VirtualBox. VirtualBox is probably the preferred virtualization software if you're using Windows, or if you're a beginner in using virtualization technologies or Linux, because it's just easier for normal people to actually use VirtualBox compared to other solutions. But VirtualBox is harder to install on Linux. I'm on Kubuntu 25.10. I'm on a Linux operating system. For me, it's actually harder to install VirtualBox to make sure it's running, it's not competing with other virtualization software for Linux kernel modules, etc. That's why I'm using the default virtualization software for Linux in graphical user interface mode, which is probably Virt Manager. It's just easier to install. It's part of the binary packages of most Linux operating systems. There's no need for out of 3 Linux kernel modules. There's no DKMS, no mess when you're updating your Linux kernel, etc. It's just the default. Okay, says that we should download the latest raw image, which we did. Then it says that we should start Virt Manager. Let's have the instructions available. Says file new virtual machine import, file new virtual machine, import existing disk image, forward, browse, and it's the only file in here with extension raw. It didn't detect the virtual machine template to use, so we're going to write in here Arch Linux, forward. I'm going to use a large amount of random access memory and virtual CPUs. Okay, the computer name, the virtual machine name will not be Arch Linux, but will be KDE Linux. Enable customize configuration before install. Okay, and this .raw file will boot if your virtual machine is using UEFI not BIOS, so let's change that. And it also requires that secure boot is disabled. Let's look at the other settings. So CPUs 14 out of 16 vCPUs, 10 gigabytes random access memory, VirtIO for the disk and for the network interface card and tablet. So these are the default, the newest virtual machine template for Linux operating system. The virtual machine is going to be fast and use the hardware resources that I have provided in the best way possible because we're using VirtIO hardware, the network interface card and the disk, the storage. Okay, and then we're not going to use the CD-ROM to boot from the ISO file. Instead, we're going to use the .raw file. So for that, we need to add a secondary storage. The first one we're going to have two VirtIO disks. The first one is the equivalent of the .iso file. And we'll have a second one, which is the actual hard disk, the actual storage of the virtual machine. Storage, 200 gigabytes, disk device, VirtIO, finish. Okay, and with that, make sure that the boot order is correct. So the small disk 6 gigabytes should be the first one in boot order, and the virtual machine should actually boot from the small 6 gigabytes virtual disk. Begin installation. Okay, so the virtual machine has started. The virtual machine is using UEFI not BIOS. The virtual machine is not able to boot from the small virtual disk because secure boot is enabled. We're going to need to enter the editor for BIOS. In here, we're going to change the next boot of the machine to not have secure boot enabled. Let's see the steps. So secure boot configuration. Attempt secure boot on next reboot should be disabled. F10 to save. Y and exit and reboot. Okay, so at this point, the virtual machine is using UEFI without secure boot, has managed to boot from the first disk. This is the boot loader with the boot menu. We're going to keep the default first option, which is KDE Linux. Here are the instructions on the wiki page on what to do if the Virt Manager virtual machine fails to boot and it says no bootable option or device found. So we pressed enter and then we're navigating the text user interface of the UEFI UI. Device Manager, secure boot, attempt secure boot, uncheck it. We pressed the space bar, we've pressed F10 to save, Y, and then escape and reset. At this point, we managed to boot in the virtual machine, but we're in something similar to the live CD mode that you have when you're booting from the ISO to then start the installer wizard to install the operating system on the actual big storage, in this case 200 gigabytes virtual hard disk. So let's see if the installer works. We can start the installer from multiple places, double clicking on the desktop or clicking on this icon, launch install system now. So that didn't work. I clicked in here. Let's try to start it from here. Okay, that doesn't work. There's probably some issue there. Let's try to run it from the command line. If not, I'm going to probably ask around and probably I'll use an older version of the .row file. Hopefully that will work. Let's find out how the installer is being started when you double click on the icon on the desktop. So right click on the icon, properties, application, probably this is the command line pkexec calamares. pk being what? Policy kit. None of the expected configuration file paths exist. So pkexec calamares doesn't run. There's at least this directory missing, /usr/share/calamares/settings.conf. And I remember that previous times when I have installed KDE Linux, the instruction said that we should check the checksum of the downloaded .row file. So in the instructions for Virt Manager, when you click on download the latest .row image, it says that you should find the .row file, but then there's a details page there. So let's look. So we have selected the newest .row file, and here is the link where you download the file that's 6 gigabytes in size. On the same row, the rightmost cell says details, and in here you can see the MD5 sum of the file that we have just downloaded. And we can compare this checksum in two ways. In graphical user interface mode, right click on the file that you downloaded, properties, and then the tab checksums, and then click on MD5. Or from the command line, I use the command MD5 sum space and then the name of the file. And it says that the MD5 sum starts with F6 ends with 66, which is very different from the checksum that I see in here. And the graphical user interface method also shows the same MD5 sum for the downloaded file. So there is the hope that maybe the file was downloaded incorrectly by Firefox. I'm going to download the file again. So I have downloaded the same file a second time, but now I'm using the suffix -1. The MD5 checksum is actually okay, starts with E7, ends with 511. So I'm going to just reinstall the virtual machine from scratch. So let's destroy this virtual machine, shut down, force off, yes, virtual machine, delete, and I'm going to delete just the qcow file. Yes. And then from start, file, new virtual machine, import, forward, browse, refresh, .row, choose, Arch Linux, forward, 14 vCPUs, KDE Linux, customize, UEFI, okay, a second disk, 200 gigabytes in size, virt.io, so let's look again. virt.io 1 should be small, virt.io disk 2 should be large. Correct boot order, begin installation. Press enter. Device manager. Secure boot configuration, attempt secure boot, space, F10, Y, escape, reset, KDE Linux. And let's see now. And the exact same error. It seems that this is not the way this raw file works, because this file is actually a read-write file, not similar to an ISO. Whereas the ISO is read-only, this is actually a file that's going to be used by the virtual machine. It's going to have the entire slash in there, the root directory of the Linux operating system. It might have files that are being created there in /temp, in /var, etc. So immediately after I use the virtual machine, I start using the .row file, its MD5 sum will change. So this is not the way to check that the .row file is correct. You actually need to follow the procedure, which is immediately after you download the .row file, make sure that the checksum is okay, and only then boot the virtual machine, because the second the virtual machine starts, the .row file will change. Hopefully I have managed to fix this. So this was the issue. There's two different Calamares installations on the live CD-like mode of KDE Linux. There's /usr/local/bin/calamares and there's /usr/bin/calamares. So with local or not. And it looks like this, which calamares. -a. So if we're running in console, in graphical user interface mode inside KDE Plasma, the session that was started by the KDE login manager, the preferred executable for calamares is /usr/bin/calamares through this symlink /bin/calamares instead of /usr/local/bin/calamares, which is the correct one. So don't, this issue will be fixed in a couple of days probably. But in the meantime, I'm going to manually run the correct one, /usr/local/bin/calamares, which is this guy. Okay, let's see if the installer works. New York, English US, current VDA1, VDA2. What is this? Yeah, I'm selecting the wrong disk where to install. So we want the large one, the 200 gigabytes one. Erase disk, a EFI partition, and the rest. Looks okay. Says that we have booted in EFI mode, not in BIOS mode. And that we're going to use the GPT partition table, hopefully. Your name. Name of the computer the same as the name of the virtual machine, KDE Linux. Let's improve a bit the graphics from the Virt Manager main menu, view and resize to window to virtual machine. Password. Looks okay. Let's look at the text scrolling by. So it's doing BTRFS action. Subvolumes, compression level 1 Z standard, /dev/vdb2, where the /root will be once we boot in the virtual machine, after we finish installing. Okay, so that was it. Probably both the .raw file, the small one, the 6 gigabyte one, and the final disk, the 200 gigabyte one, both use BTRFS subvolumes, and the way that you usually copy between BTRFS subvolumes, similar to what you would do if you would use the file system ZFS. So restart now, and the done button is at the wrong place, should be at the bottom right. It offers to reboot, which is great, but we actually want to not boot again on the live CD-like experience. So we want to shut the virtual machine down and remove the disk one. Let's see if shutting down works. Shut down. Let's read a bit of the instructions. So yes, the instructions on the wiki page seems to be okay. I'm not sure where it says that we should stop the virtual machine. In here it says in here. So after installing the OS is done, shut down the virtual machine. So maybe in the installer we should have unchecked to reboot and shut down manually. Okay, so it says that virtual IO disk 1 is the similar equivalent of the ISO file. And then we want to remove So edit the virtual machine configuration, right click on VirtIO disk 1 and remove hardware. Delete the associated storage. The associated storage is going to be the raw file plus modified because we have booted off it. So probably the instructions should say something like, after you download the raw image, the .raw file, maybe it's a good idea to make a backup of the raw image if you want to boot again from it, because again, the small 6 GB raw file is going to be edited once you start the virtual machine. So we'll not delete the file. We did not check the checkbox delete associated storage files, which will delete the raw file. So just delete the VirtIO disk 1. Okay, and now says that the name of VirtIO disk 2 has changed into VirtIO disk 1. There's just one VirtIO disk 1. It contains the operating system installation. And we're going to start the virtual machine. No need to look at the boot options because the larger VirtIO disk will become the default boot option after you delete the small virtual disk. Okay, so this is probably not SDDM, but the new login manager from the KDE community. Let's prove that's the case. It should look very similar because it's an evolution of the same code base. The SDDM source code has become the new login manager. I want to have the KDE terminal console favorited. So when I start the start menu, it should have console there. Okay, PS3. And instead of SDDM, we now have the executable Plasma login. And it's not using X11, it's using Wayland. So there's no X11 normal server in here, there's just X Wayland. So straight on top of the hardware sits Wayland, both for the session of the desktop manager, which is called Plasma Login, and also for the session of the KDE Plasma graphical user interface session of the current user that we're logged into right now. So this is the KDE Plasma session of the current user, starting with this parent process. And the session of the desktop manager is this process Plasma Login with its children. The rest are other system level services. Let's try copy pasting text from the virtual machine. It does not work. I'm used to not being able to copy text between the virtual machine and the host machine when I'm using Virt Manager. And the usual workaround that I use is to connect to the virtual machine in text user interface mode via SSH and in graphical user interface mode using the remote desktop protocol. Or if that doesn't work, then VNC. But then KDE Linux doesn't have an X server. It's a Wayland operating system. So I don't really know how to install either a VNC server or a RDP server, remote desktop protocol server. But I do know how to enable the SSH server because the SSH server is installed by default. So let's see that. Okay, so sudo works out of the box. It uses my user that I have created during the installer. And we'll see if SSH is installed. It's installed. The systemd unit is available. Let's enable it now. It's running. Let's connect to the virtual machine. Network interface card, properties of the virtual machine. Copy the IPv4 address. Open console. SSH administrator. It refuses because the IPv4 address has already been used. Now it allows the connection. Okay, so I could connect in text user interface mode via SSH. Would be nice to know how to connect in graphical user interface mode using either VNC protocol or remote desktop protocol. Okay, at this point we have the operating system installed, KDE Linux. I'm going to connect to this virtual machine and continue the screen recording from inside the virtual machine, and then we're going to continue with the rest of the procedure, which is this wiki page. Develop KDE software. I have tried to enable the remote desktop protocol server. Inside KDE Plasma system settings, I wrote RDP, takes you to networking remote desktop. In here I have enabled my user, I have enabled auto start at login, and this checkbox doesn't really work, enable RDP server. But still a remote desktop protocol server is running, but only after you log in into the graphical user interface KDE Plasma session as the user admin. So if you're logged off, if you're logged out, if you just restart the computer and the only graphical user interface thing happening on your computer is the desktop manager, then I could not connect using the remote desktop protocol. But if I am logging in from the desktop manager in KDE Plasma, then I can try to connect using a remote desktop protocol client, and that actually requests the password of the user administrator. The password is verified, is okay, but then the connection closes, the KRDP server crashes, it says something that the user has closed the connection, which is not the case. So part of the remote desktop protocol server is working because I can see it asking for a password, checking the password, making sure the password is okay, but then immediately after that, things don't really work. Okay, so right now I'm creating the screen recording with just the content of the virtual machine inside the Virt Manager, which means that I'm going to need to do some changes on the virtual machine first. Okay, Breeze Dark is the default cursor's theme. The experience in KDE Plasma should be extremely close to what the upstream KDE community wants, because the operating system KDE Linux comes from the upstream from the KDE community. So this is part of the terraforming things that I always do just to survive. Okay, and also for Firefox. And also I make sure that the KDE Plasma main panel is not floating. How do I do that? Show panel configuration, and it should not be floating. Okay, don't import anything. Configure the thing. So this is me configuring the look and feel of the web browser that I actually use, which is Mozilla Firefox, which comes pre-installed in KDE Linux operating system. The number of settings that I always do in KDE Plasma is around, I don't know, 5. So it's possible for me to remember. And the number of settings that I do in Firefox, except for removing unneeded buttons, is also around 5. But year after year, the number of settings that I just must do increases. New in Mozilla Firefox is the suggestions. Okay, so that's it. And I'm using Mozilla Firefox in a private mode, incognito mode. I'm only using Mozilla Firefox in a non-private window mode when I'm actually logged in to an online account. For the things where I don't use an online account, I'm not logged into any account, I'm just going to use a private browsing window. The same search term in Google search, KDE Wiki, KDE Linux, KDE Builder. This is the page that we're after. So it says that you have a fresh installation of KDE Linux, but you're a KDE developer or you want to start contributing to the KDE community as a developer. What can you do? And you want to, of course, compile software. The KDE Git repositories with graphical user interface applications and other supporting libraries are probably using the C++ programming language with a bit of QML programming language. And that requires that you have a toolchain. You need to have Qt installed, the Qt headers for C++ development, the Qt libraries, the other libraries and packages that are needed by the KDE software, which are not part of Qt or part of the KDE project. And at this point, you have multiple options, but some of these are if you just want to compile to build an application that has support for being built as a flatpak x86-64 AMD64, then that might be an option. You just download, you just git clone that Git repository and build the flatpak. Let's actually start this way. So there's two different chapters. One's for building the source code from source, but from Git master branch, but also packing that thing as a flatpak package. And the other option that we have here is using KDE Builder, for instance, as a additional value add for KDE Builder. The software that's actually installed on this computer and it's from the KDE community, such as Plasma Login, KWin, the window manager, Wayland Compositor, the KDE Plasma environment in general, and some of the applications in here, and the supporting libraries, so KDE frameworks and other libraries, are built from source, from Git master branch, and are built using KDE builder, and they're installed on the system in /usr with everything that's needed to build using KDE builder, in the sense that most of the KDE frameworks version 6 are installed in /usr, and there's both the binaries or .so files, but also the support for developing, which is the include files in /usr/include for those KDE frameworks that are built using KDE builder, and part of the raw file that we have just installed and available on the installed system under /usr. So in /usr, there's two things. There's binary packages from Arch Linux installed there, but there's also KDE software built from Git master branch using KDE builder, which is a build framework from the KDE community, and installed into the same prefix into /usr. So the flatpak part seems simpler for me at this point, so let's follow this part of the tutorial first. Okay, so let's read. We should have flatpak pre-installed. Let's see if that's the case. Okay, so which flatpak? It's in here. Control left doesn't work for me, so I'm just going to change the shell to bash. So bash maybe has different keyboard shortcuts for read line, because control arrow keys works as I expected, which is to jump one word to the left or to the right. Alt backspace also works for deleting the previous word. Okay, so let's see what it says in here. It says that we should have flatpak builder available out of the box. And we do. And we should probably also have Git out of the box. And G++. And clang++. Let's see. What's the default C compiler? It's a GCC. Okay. Okay. There are some executables which are provided out of the box in KDE Linux. In KDE Linux, that's not that easy to install software, in the sense that half of what's available under /usr comes from the Arch Linux operating system, but you cannot install Arch Linux packages because the command line package manager is missing. And because /usr is read only. So /dev/vda2 is mounted on /. It's btrfs. It's the subvolume named at system. and then /system is the subvolume slash from btrfs. And also from btrfs comes the storage for snap, the snap file system, /var/lib/snapd/snap. /boot is vfat because we have booted in UEFI mode. Okay, so let's see if we already have any flatpak remotes available out of the box. Something about remote listing. Okay, what do we have in here? So I can see a ton of, I'm not even sure what I'm looking at. Yeah, I'm using the wrong flatpak command line. List the contents of the configured remote, but I want to list the configured remotes, which is just remotes. Okay, so multiple flatpak remotes are enabled out of the box in a KDE Linux installation. All are installed per system, not per user. The most important here is FlatHub, installed per system, which people would expect. If you say that Flatpak comes pre-installed with your Linux operating system, people expect that the Flatpak remote FlatHub is already configured and is available per system to all of the users on your Linux operating system. So we said that /usr hosts files that come from Arch Linux binary packages. Arch Linux is a rolling Linux operating system, so it has software as fresh as the latest releases. So for the software that's packaged in the official Arch Linux repositories, once a new release of the project is created, a couple of days later, the binary package for Arch Linux will be updated and pushed and available into the Arch Linux package remotes, which means that KDE Linux will have all of the Qt, non-Qt and non-KDE software be as up-to-date as possible. So released software, not Git clones. Once software is released by other parties than the KDE community and Qt, and it gets packaged for the new version gets updated for the Arch Linux packages, new versions will be available in KDE Linux. KDE Linux tries to build a new raw file each day, nightly. Okay, so the software that comes from Arch Linux is pretty up to date. And then the rest of /usr is KDE's software, minimal amount of KDE repositories. Just the KDE frameworks are probably, I don't know, 60 Git repositories. The rest of KDE Plasma, another 50 probably. So there's probably, I don't know, 200 Git repositories from the KDE community, Git master branches that are being built using KDE Builder and available on my system right now in /usr. And then, in addition to that, some of the graphical user interface applications that we have installed right now and available to me come from Flatpak nightly. So there's not a single KDE remote for Flatpaks, for nightly Flatpaks. There's multiple ones, each for each KDE application that has a Flatpak nightly GitLab CI automation enabled. There will be a different Flatpak nightly KDE repository. So if you have just 6 Flatpak packages installed from KDE nightly repositories, there will be as many Flatpak repositories, which is 6. So 6 Flatpak repositories, 6 KDE applications. Okay. So the instructions say that we should make sure that we have the FlatHub available remote, because maybe we'll install some software, not us, but actually the executable Flatpak builder. Or, yeah, because Flatpak builder is building, so it might patch from FlatHub some binary packages for build support, such as SDKs, platforms, extensions, etc. But also after the binary Flatpak is being built by Flatpak Builder automatically will install the generated binary Flatpak, and that might also need some dependencies, and those will get installed also from FlatHub. Okay, so this step, adding a second remote towards the same place, which is the FlatHub repository, but one per user, is such that you can install packages without using sudo when you run this long command line with Flatpak Builder. So yeah, it's a good idea to add the Flatpak repository twice. Okay, so per user named FlatHub apps built locally, and per system named FlatHub. 2 different Flatpak repositories pointing to the same URL, which is this guy. Okay. Then it says that we want to git clone a KDE Git repository. Let's actually find this repository and make sure that it has a .flatpak manifest.json file available. How do we do that? Okay, so on Google I have searched for KDE invent FileLite because that's where the Git repositories are. There's a GitLab installation on premise, and the URL is invent.kde.org. And FileLite is the name of the KDE Git repository and of the project and of the executable, etc. So let's go there. https://invent.kde.org/utility/FileLite. And top level in here should be a hidden file named .flatpak-manifest.json. Let's look at the file. So it's a JSON file that says that in order to build KDE FileLite, we're going to use the current directory. So we need to have a git clone of the repository. We are going to use the org.kde.platform version 6.10. And while building, we're going to use the SDK from this platform, from this version. So this is the runtime dependency, and this is the build time dependency. inside of the binary package that we built, there will be an executable named filelight. And if we install this flatpak package, binary package, in the KDE start menu, it should say filelight and then have this in the name. So space and between parentheses nightly. Okay, says that it needs to do graphical user interface things, so either Wayland or fallback X11. And it's a file management tool, not a file manager, but a file management tool. And for that, it requires access to the file system. How this software is going to get built, so we're going to manually git clone the repository, and then from the current directory, inside the flatpak builder container, the platform will be installed, the SDK will be installed at the correct version, and then in the current directory, Flatpak Builder is going to run a very long cmake command line, including this command line parameter -dbuild _testing equals off, so not build the automated tests, the test suite. It's going to use cmake, it's going to be fast because it's going to use Ninja. And that's about it. Extremely short flatpak -manifest.json file, which means that the bulk of the configuration is not in here, but is in here and in here, inside the platform and the SDK and their extensions, and inside the runtime and SDK that's underneath this, the free desktop runtime. So let's see how things work. Continue with the instructions. Says make the directory ~kd/src if it doesn't exist. If it already exists, not a problem. Go into that directory and then git clone the git repository. I'm not sure what this thing is doing. I'm not sure if it's okay. It should clone via HTTPS. Let's see if this thing actually works. It saw that I have already connected via SSH. And permission denied. Of course, permission is denied because git clone with the git protocol is for writing to the git repository, and for reading we use the HTTPS protocol. Okay, so git clone and then this. Okay. Next up, we go into the directory of the git clone. In here, there's this hidden file, top level.flatpak -manifest.json, which we're going to use using this long command line invocation of flatpak -builder. So let's see what it says. Flatpak builder, one of the possibilities of building flatpak binary packages, verb build, do it per user, not per system. It's going to install dependencies from this repository, not from others. It's going to do a rebuild, not an incremental build. And after the binary flatpak is being created, it's also going to install it. And because we're installing dependencies from a repository which is per user, and we're installing the flatpak for filelight per user, we're not going to need to run this command line elevated by prefixing it with sudo, for instance. Let's see what it did. So flatpak builder will create a container similar to, I know, Docker, where it's going to install dependencies, and these are, so the actual binary flatpaks are being downloaded on my computer, and they're going to be installed in my home directory and made available to just my user, and then made available inside the flatpak container that is running. And these are the org.kde.sdk version 6.10 from the flatpak repository that we have specified. And then it found extensions already available on the system, hopefully. Nope. Okay, and then it needs also platform, org.k.platform version 6.10 from the same flatpak remote. These are some flatpak extensions. So there's one runtime, one SDK, and all sorts of extensions for translations, or graphic GPU acceleration, or audio-video codecs, or themes, more translations. Okay, after the container is done and the correct things are present inside the container, it sees that there's nothing to download because we're using the current directory, and it starts to build everything. Inside this manifest, there's just one module named -1 in this case. So file light. Let's see where building takes place. So tilde/kd/src/filelight is the directory where we git cloned. And in there, there's a hidden directory .flatpak-builder and build and all of the modules, just one module named filelight. So filelight -1. And what it does in there, it's running cmake-configure step with this additional command line parameter. This is the output from cmake-configure step. There's a warning. And flatpaks use this interesting file system layout where /app is the application itself, the final module, whatever the entry point of the modules, the entry point of the flatpak, in our case filelight, and then inside /usr will be available the runtime dependencies, such as the org.kde.platform. That's why it says, CMake says, installing in /app directory. Okay, continues the output from cmake-configure. It finds everything, but it finds everything not in /usr, but inside the flatpak container. And this everything is provided by the combination of these two things, org.k.platform 6.10 and org.k.sdk 6.10. There's including KIO in there. So no need to build KIO, for instance, with all of its dependencies and extensions, etc. Okay. Where does it say about Kirigami? org.kd.kirigami. Runtime dependency. Okay, it found the Qt modules, many of them, quick controls to dbus tools, QML tools, QML core tools, GUI, etc. KDE frameworks, ECM, KIO, internationalization, color scheme, config, crash. Okay, at this point, the CMake configure step finishes and the Ninja step starts. So similar to the GNU make step, which just builds everything without installing. There's some warnings about this pt_br localization, which I'm not sure why we cannot just fix. It affects all modules when building using KDE Builder or building up images using KDE Craft or building using flatpak builder, etc. And it's just noise and only happens for just one locale, pt_br, not for the rest. There's C++ warnings, unused parameter. Okay, and that's it for building. It says that it has created a binary file named bin/filelight. And at this point, still inside the flatpak container, it's creating a directory /app. And in there, it's make installing. It doesn't really use GNU make, but it uses Ninja. So it runs the command line Ninja space install. So inside the directory /app, a file structure similar to /usr will be created. A bin directory, filelight the executable, share with icons and translations, /share/doc with HTML product manual, the handbook. And then this is where Ninja install finishes. It's looking at the debug info. Probably everything was built with CMake build configuration rel with deb info. Let's see if it says that. Right click. Where is it? The main menu. So console, let's show the main menu from the hamburger menu, more, and then show menu bar with all actions, Ctrl+Shift+M. Edit, select all, edit, copy. And let's see what text editors we have available. Where is that? All applications. There's kwrite. And kwrite actually installed from KDE Flatpak Nightly remote. Let's find rel with debinfo. Nope. So I'm not sure what CMake build configuration is being used, but probably rel with debinfo. That's just the default. And then debug symbols are being stripped from the executables. So rel with debinfo .so files and executable ELF files are going to use C++ optimizations, but the debug symbols will be inside the ELF binary files and .so files. And then they're going to be stripped using the executable strip, and are going to be put somewhere. So compressing debug info. It's still working on debug symbols. This is probably the output of strip. I do not know. There's stages in when building flatpak, similar to the steps that exist when you're building a snap package. There's a stage named build minus filelight. Okay, it's moving the up data somewhere. It's editing the .desktop file. I'm not sure what this output is. It might be a warning, so a chance to fix it and do a git commit, git merge request, GitLab merge request, and contribute to the KDE community. If it's indeed a warning, let's fix it. If we're showing this text for just no reason, there's no error, no warning, no nothing, we should not display it here. It sounds like you're doing something wrong, only accepting components. Okay, next up. It's working on the metadata. It's working on the up icon. Non-allowed export file name. So maybe it prefers that the file name for the icon is org.kd.filelight.png. And who knows, maybe it even prefers the extension to be SVG, not PNG, and the icon to be just freely resizable. Okay, there's a repository. org.kd.filelight, the binary flatpak has been exported there. It complains one more time that the application icon is not named org.kd.filelight. It's creating another binary flatpak package, org.kd.filelight.locale. So first flatpak package, org.kd.filelight. The second one, org.kd.filelight.locale. The third flatpak binary package with ending in .debug. So it says that it has put all of these three binary flatpak packages into the repository. It doesn't say which repository. And then it says that it has installed all three binary packages. So the org.kd.filelight, the one ending with .locale, and the one ending with .debug. Probably the one ending with .locale contains the product manual in other languages than English United States. And this probably contains the debug symbols that have been stripped from /up/bin/filelight executable. Let's see what's available in the current directory. Nothing. Let's see where the files, the binary flatpak packages are. No Midnight Commander. Let's dig. Okay, so KDE src. Let's show hidden files. Let's show the menu first. So let's display the Dolphin main menu from the hamburger menu. More, show menu bar with all actions, Ctrl M. Unfortunately, the shortcut isn't always the same. It's Ctrl M for FileLite, Ctrl Shift M for console to show the main menu. How do we show the hidden files? From the Dolphin main menu, view, and show hidden files. Okay, we know that there's a .flatpak-builder directory. There's also another one that's not hidden, which is the directory build. Let's see which is which. Okay, I just don't know. Let's search. The search application that doesn't use any search index, it just looks at the file system and searches for files, which is called kfind, is probably not installed because I cannot see it available in Dolphin. If kfind is installed, Dolphin detects that kfind is available and it's going to offer it as an option inside the tools menu inside Dolphin. So in here, in Dolphin main menu, tools, there should be a, I don't know, kfind or find files entry. Let's see if this search works. The search that's available out of the box in FileLite. So I want to search in this directory for all of the files that contain flat in the name or directories. So /sys, it totally is not in this directory. So I don't want it to search into /sys, I want it to search in the current directory. And it also lies, it says that search results for flat in FileLite, so in this directory. So from what I see, both here and everywhere do the exact same thing. Return the same results with /sys and /var. And it's looking at the BTRFS subvolumes. Okay, so from what I see, the binary flatpak packages don't exist. The remote that we have installed per user probably does contain the 3 binary packages, but they're not available in here in the current directory. In the directory where we have git cloned FileLite. I can see something similar to a git file system. In the current directory, hidden directory .flatpak-builder /cache/refs, where I see, I'm not sure what these things are. I don't know, git branch, similar to git branches or similar to git tags. I can see all of the 3 names that I would expect. Okay, let's prove that the repository contains what we expect. So flatpak help, and now we want remote ls. And we want to only list the FlatHub apps built locally. Yes, we want to only list the Flatpak repository FlatHub -apps -build -locally, but only the packages that are installed currently on the system, not the ones that are available in the remote. Or not. Oh, the flatpak remote action is something. So let's look at the flatpak packages, binary packages that are installed on the current computer, but just for my user. Okay, so I have from FlatHub apps built locally, which is just FlatHub, all of the dependencies of the application FileLite. And then from another Flatpak remote, which is called FileLite minus origin, I have installed the actual graphical user interface application that I have just built, which is org.kde.filelite. And then between the available remotes, there's another one which is available per user, and it's called debug minus origin, where org.k.file.debug flatpak binary package is available. So per user, I have at least 3 remotes, maybe even 4. One named FileLite minus origin, another debug minus origin, and probably, I know, one for locales. And from FileLite origin, I have installed the actual application. I do not have installed the debug symbols. Okay, and FileLite has its dependencies twice. Once from remote FlatHub and once from remote FlatHub minus apps minus build locally. If I see things correctly. In this case, Omesa, the same reverse DNS identifier, the same version, the same branch, but installed once per user, once per system from 2 different Flatpak repositories that point to the same FlatHub URL. Oh. The unexpected part is that this appears as being installed. Maybe the same files are available just once in slash, not in the home directory of my user. But then I'm not sure why it's reporting as being installed twice. I'm not sure how the deduplication works if you have the same binary package installed both per system and per user. There's totally file deduplication. If you have 2 very similar Flatpak packages and you install them per system, then the special file system that is there that handles Flatpak binary packages, which is similar to a Git repository, will do deduplication. It uses hard links, but then what does it do between my home directory, the home directory of my user, and the slash directory where the Flatpaks that are installed per system get installed? Maybe it just creates hard links in my home directory. Yeah, but it's still, I'm not exactly sure why it reports this thing as being installed when it was already installed correctly per system. Couldn't it use that one, the one installed per system? Okay, the application was already installed. I can see the application in multiple places. utilities, there's this green dot to say that a new application has been installed, has the correct name, FileLight, and then nightly. Probably the exact same thing I can see as integration in Dolphin in the main menu, tools, and says manage disk space usage. And there's disk usage statistics for the current folder. Okay, let's see the largest files in here. This guy. It's a debug file. How do we go back? Backspace. Yeah, I'm intrigued why there's no back button. Or a URL bar where I can select the file, like this one, where I can delete parts of the full path of the current directory. I don't even know how many directories must I go up. I should stop here, okay? So let's see what is this thing. So this is this is a Git clone with the entire complete Git history of the KDE Git repository for FileLight inside top level hidden directory.git. This is a debug file. So this graph only shows directories from what I see. It doesn't show individual files, which is unexpected. How can we make it show files? Show small files. What is that? Yeah, it's still not showing individual files in the graph. There's something wrong here. The tooltip is too long, and there's some tooltip being shown on top of another tooltip. Yeah, it's showing both a tooltip for a directory. There's that is 1.6 megabytes in size, and for another one that's and no. Oh, it's an overlay of wow. This is the top level directory minus the .git directory. Why would I be interested in seeing such a thing? I'm not sure what I did there. Let's undo this show small files thing. Yeah, so maybe that feature is not that complete. But here is the feature again. So it selects a random number of directories from the current directory. Strange. So it selects the /src directory, all of the top level files, but doesn't select the PO directory or the build directory. Maybe these are git ignored, or who knows what's happening there. Maybe FileLight considers git ignore. Okay. Let's see if we can start. What did it just happen? So there's no line wrapping in here. It truncates parts of the text. What are we looking at? We're looking at crashed processes viewer, which is what? So the executable is named /up/bin/filelight, which is a directory that only exists inside the running flatpak container. All of these files in /usr/lib are not from the host operating system from KDE Linux, but are inside the running flatpak container while the application filelight is running. The flatpak org.kde.filelight application is running. Okay, what does it say? There's a core dump, compressed Z standard. Let's see what this button does. Enable debug info D. No. Segmentation fault. On Google, I searched KDE Wiki GDB. Takes me to the correct wiki page, debugging with the GDB. In here, we have how to run an application from scratch inside the GDB. That's not our case. Attaching GDB to an already existing application, nope. And we have this guy debugging core files with GDB. Okay, so what we want is to see the backtrace. How do we search for that? So here it is, the command, it's bt. So I'm not sure what I'm seeing here. I'm not sure what's happening, but I can guess. So we are, we have a core dump. So a process has crashed, the Linux kernel has caught that thing. Systemd crash handler core dump D thing has put the core dump, so the mini dump, the image dump somewhere. And now we're running GDB attached to that dump file. But the dump file was created by the Linux kernel while the flatpak container was running. So the flatpak container, seen from the Linux kernel mode, is just a regular process. The Linux kernel doesn't really care if it comes from a Linux container or from the normal / directory or from a chill root or from other technologies, containerization technologies in Linux. So it has written the memory of the process /up/bin/filelight to a file. I'm not sure if everything, all of the random access memory used by the filelight process has been written. Maybe some parts have been skipped. But still, we don't have the debug symbols of filelight. Not at /up/bin/filelight. They have been stripped there, and the directory /up/bin doesn't exist outside of the flatpak container. And then the same thing for the rest. Some of the Qt files could be found and loaded by GDB, but it's the wrong file being loaded because the libqt6 qml models.so.6 does exist both in /usr/lib coming from Arch Linux binary package, but also exists inside the flatpak container, and the two files are different. Yes, they have the same full path, the same file name, but they're totally different. They have certainly different MD5 checksums. Okay, and then it says that indeed it doesn't have debug symbols for nothing, because we can see question mark in here. It does have some debug symbols when the function, whatever the C++ method, static method, or object method that's part of the call stack is actually exported from this DLL, for instance, in this case, then yes, it can compute, GDB can compute the maybe correct name of the function and which overload of that function. But that's just luck, because one, we don't have the debug symbols for this file, and two, we have the wrong version of this file. Okay, and the error is something about QML. Maybe it's the work in progress issue that we have right now. Let's actually see if we can create a correct backtrace from this flatpak application. There's slim chance, but let's see. Create a new tab. Let's see if there's a GDB process in here. What did I actually do? So GDB with a file name and a TMP thing. Wow. So it's actually running GDB inside the container. Bubble wrap. That's pretty cool. How can we enter this container that's running right now and install in there the debug symbols? So let's see where I got. This is my wiki page in mariusp.github.io. The last URL in here. Advanced topics. Flatpak. And in here it says how you build software using Flatpak, but also how you debug issues using GDB inside the Flatpak container. So for this, we're going to list the running Flatpak containers. This thing, PS, enumerate running applications. We can see that a application is running, the filelight that has as runtime the platform. Let's exit from this one. How do we close existing ones? Kill. Enter the namespace of a running application. So this is the crash dump, the mini dump. I have copied it from the directory where it was generated, somewhere under /var into my home directory, straight into the home directory. And now I'm trying to follow the procedure and see how far I get. So it says that you should be able to run the flatpak, which I can. That you should have FlatHub, which I do. I have built. I can enter a container. Okay, and this is org.kd. Highlight. Let's list the list of installed flatpaks. Let's copy this thing. How do I find the text editor? Add to favorites. Control V. Okay. And what should we look for in this list? We want all SDKs and all debug flatpak packages. There's this option, include debug. Okay, so let's see which of the installed packages could have the debug part installed. There's the free desktop platform. There's the SDK for KDE. And there's no debug symbols for FileLight. For all platform extensions, extra data. Yeah, we could skip this thing. Let's see this thing, what it does it do. So Flatpak install user include SDK include debug. The name is FileLight origin, and there's also debug minus origin. Yes. So hopefully this is it. it says that org.k.filelight.debug is already installed. I saw how the .debug package for org.kd.sdk has been installed, and that was huge. It was several gigabytes in size, and it took a while to download, but that should provide us debug symbols for the Qt .so files and the KDE.so files from within the flatpak container at /usr/lib. And now we have this container that we don't want to run, the one with FileLight. So I went flatpak space ps, similar to the Docker command line. Lists the running containers, and we want to kill this container. Okay, and now we need to run the flatpak container for org.kd.filelight, but with the most debug and SDK support as possible. We want all of the possible executable debug symbols, everything in there. Debugging tools, everything. And we also want the current directory, because the current directory contains the dump file. Okay, we can see the home directory of the current user. I'm the user administrator. And now I should be able to open that symbol with GDB. So this is the command line syntax: GDB, the full path to the executable, and then the dump file. Let's see if we have what do we have on the path environment variable first. So /app/bin should be first. Where is FileLight? Should be in /app/bin, which means that we can use the short version. We don't need to provide the entire path, but we could. So either GDB and the full path to FileLight, or just GDB space FileLight. And then the second parameter is the name of the file, this guy. I'm not sure if we need relative paths or just the file name is okay. Okay. And go. What should we do next? Says that the standard file is not a core dump. Let's exit. Let's un-standard it. How do we do that? Okay. So there's a file with the exact same name, but without the z-standard extension. Okay, so the exact same command line, but without the extension. GDB, the name of the executable, and the name of the mini dump. And what does it say? Okay, it says if I want to use the debug info server, debug info D, nope. C continue without paging. And we're at the same place. It determined that we have a segmentation fault, 6seg, but everything's way more readable now. We have the name of the CPP file where the body of the method QQML delegate model item destroy object is where the source code of this method is. We also know the line, so line 2573, and in there's a if q unlikely static cast q core application private about to quit emitted. Yeah, maybe there's some issue when the application closes. It's a QML application, uses, I'm not sure if it uses Kirigami, hopefully it does. Yeah, but now we have a as good as possible stack trace. Let's see how it looks like. Okay, so absolutely all of the lines inside the stack trace contain a correct method name, a correct CPP file name, a correct line number. So it's something about cleaning up maybe the QML engine. About caches, something, yes. And we have this issue in flatpak QML applications where there might be some issues if you don't refresh, if you don't clean the QML cache. And that is being done by deleting the directory tilde/var/up/org.kde.filelight/cache/filelight/qml cache. Hopefully the KDE community has an operating system which is called KDE Linux, does publish flatpak applications to FlatHub that includes the flatpak org.kde.platform, org.kde.sdk, their debug symbols. So all of those are available in the stable branch in FlatHub. So should also be available to the KDE community. And then the application that handles application crashes, Dr. Conky and other automations that exist in here, see when an application crashes, has access to the core dump, and maybe it uploads maybe the entire core mini dump, the core dump, or maybe it uploads the output that we saw previously. So it starts GDB inside the correct container or org.kde.filelight with the correct SDK. There's GDB in there, but there's missing debug symbols for org.kde.sdk and org.kde.platform, which means that the stack trace, the core stack, will not look perfect, but it will be correct. So it will miss all of the line numbers, some of the will miss all of the full paths, so the directory where the CPP file is located, but it will have at least the number of elements in the core stack correct, and maybe these numbers, these whatever pointers, correct. which means that if you upload an incomplete call stack using the tool that's inside KDE Linux operating system, then a thing that's called probably symbolification can be performed server-side on the KDE servers, which will convert just this information and nothing else to this information. Whatever, just this information to this information. Because the KDE community server-side does have access to the debug symbols, so to the file org.kde.platform.debug with an uppercase D that's stored in FlatHub. But if you want to do the symbolification yourself, you're going to need to follow the steps that I did, which is install all of the .debug packages possible, including the .debug for your application. But in this case, the core stack didn't contain anything from my application. It was everything from /usr/lib/something about Qt.so. And all of these debug symbols do exist in org.kde.platform.debug. There's no need to actually install the debug symbols for the application that we have just built, KFileLite. Only this part of the core stack will not be able to be symbolified. The rest will just work. Okay. With that, we have most of the things about how to build flatpaks on KDE Linux. Okay, let's make sure that no container keeps running. How do we do that? Flatpak ps, and the container has actually disappeared when I have exited GTB, and then the container with Ctrl-D, Ctrl-D. I don't see it in the output of flatpak ps or .kde.filelite. Let's go to the third chapter. So there's 3 ways of building which are documented here, using sysexts, using flatpak, and using distrobox. Let's see if these instructions still work correctly. Distrobox is still available. Podman is still available. Docker is available. Okay, so we're going to use distrobox, which hopefully is a wrapper on top of Podman. Podman is something similar to Docker. It's going to go to this repository of Docker style images. So OCI image container. We're going to have a directory where the home directory of the user inside the container is going to be. Because distrobox by default will map the home directory of the current user inside the running Docker container. Which means that if you're running a application that's not best behaved inside the Docker container, that might write its configuration files into the home directory of the user inside the container, but also in the home directory of the user outside the container on the host computer, and that might create bugs. So by running the same application both inside the container and outside the container, maybe the application inside the container is newer, will upgrade the configuration files, and then the application inside on the host machine outside the container, which is the same application but an older version, will not be able to load its own configuration files because they were upgraded to a newer version. There's all sorts of complications. If for debugging purposes, for development purposes, you're by default using the same directory, both for development containers and for the host computer. So I use separate home directories. Okay, it says that the OCI image for Arch Linux or Docker, it does not exist on the current computer. Do I want to download it? Yes. It's going to use the tag latest. It's going to download all of the layers of the image. It's creating a container named kde-builder container using the correct image, Arch Linux latest. That was not a question, so it says creating, which means that it takes a while. I did not actually need to press enter. It just took a while to spin the container the first time. Okay, so let's see if we're using Podman. How does Podman PS work? Yes, minus all. The container was created, but it's stopped right now. Has the correct name, KDE builder container, started from the correct OCI image, Arch Linux latest. And we can enter inside the Podman container. Distrobox does a bit of maintenance inside the containers because the Docker containers by default are built to be as minimal as possible, whereas Podman wants to have certain packages pre-installed inside the Podman container. So distrobox will install additional software in here. There is no no configuration file for the command line shell z shell because we're using a totally different home directory than the home directory on the host machine. What does it want? You are seeing this. Can help you create a few settings that make you use the shell easier. Okay, so I want probably the tilde/.zshrc file to be created. So I want 0. Now I'm inside the container. So probably Z shell was run inside the container. And why has it been run inside the container? I don't know. Why didn't it start bash? Let's see if bash is available in the container. It is. We're inside the home directory in the container. Let's see that it's empty. And it's not. Why is that? I don't know. The directory KDE builder container was created, home, and it's oh, I understand now. So the command line worked correctly. A empty directory has been created tilde/kde builder container _home. But then when I entered the container with distrobox enter KDE builder container, it has actually changed the directory to where my home directory is mounted. And my home directory is mounted by default at /run/host/home/administrator, which makes it easy to run, I don't know, for instance, a text user interface text editor application, and you can edit all of the files in your home directory on the host machine. Cool. Okay, so distrobox enter and change into the home directory. And now I'm in the correct place, which is the KDE builder container underscore home in my home directory. And the directory is empty. Almost. Okay. Then maybe we want a text editor. So this is going to be a Docker container, a Linux container, but it's going to be probably a long-lived one. So it's not the way you probably use Docker in production, where the Docker container starts. It's already fresh because it has recently been created, built, and it just runs 10% of your application, like I don't know, just the MySQL database, or just the graphical user interface, or just the WordPress HTTPS website. In here we want to have pacman, to have up-to-date metadata about the packages that are available in the Arch Linux binary package repositories. We're going to install software. Maybe this container will be with us for the next weeks. Okay. And it says that we need to make sure that the standard tilde/.local/bin directory is respected. So it's in the path environment variable at the start of it. So let's see if that's the case. Very strange path environment variable. It's actually the one from the host computer, which is really, really not okay. So there's no tilde/.profile file in here. There's a z-rc. I can see it's Z shell because I pressed Control left and it didn't work. It didn't jump one word to the left. The file is empty. Wow. How do we get back to a sane path environment variable? I don't know. Okay, and now we're adding tilde/.local/bin to the path environment variable. The file tilde/.zsrc only does that, so it prepends to the path environment variable tilde/.local/bin, but we want to apply that. Either we start Z shell again, or we exit and enter the distro box. So let's re-enter the distro box. Okay. It started in the correct directory. And the rest is history. Just follow the steps on how to set up KDE builder. You go to kde.org, get involved, development. You have the correct operating system. We're on Arch Linux. Okay, what else? We want to set up KDE builder. Let's see if we have curl. We do. Let's see if we have git. Nope, we don't have git. Pacman, no need for that. If we have curl, it's okay, and bash. It's installing git at this step. Okay, and says that there's no code completions for the shell. I don't really need those. Okay, and then you generate a configuration file. You install binary packages from Arch Linux, and then you start building using KDE Builder. You will be able to run graphical user interface applications because you're using distrobox, and distrobox, this is the main selling point of distrobox compared to just plain Docker. The fact that it exposes your home directory inside the container, and that you can run graphical user interface applications that are running inside the Linux container and have the graphical user interface, the GUI, available on the host computer. So it's either the application is using Wayland, or either the application is a Wayland client or an X11 client. It's using either Wayland or X11, and it's going to use the Wayland compositor on the host machine or the X server on the host machine. Okay, that's about it for KDE Builder inside the container inside KDE Linux operating system. Next up, how to use sysext. So we're talking about systemd-sysext. Let's do a bit of cleanup. Exit the container. We could clean up the container. So that's done with podman ps -all. We have a container there that's not running. It's still running, so we need to kill and remove the container. How do we do that? Stop. Okay. So podman ps, podman stop, container ID, podman ps again. It's stopped this time, but it's still available, just stopped. And we need to clean up. From directory a.txt. So this is the XDG portal. There's no delete. We can remove containers and remove images. So podman rm container ID ps all, nothing to show. Images list. images. Just one, which we can remove. RMI. No images. Okay, that was that. So let's see what it says. So we're in KDE Linux on the host machine. We have /usr, which is an overlay of in the same directory /usr, there was software installed using pacman, and then software installed using KDE builder. And now we want to install more software in /usr, but then /usr is read-only. So what we do, we install software in a directory, and then we overlay that directory on top of /usr. But we need to have a very similar directory structure in that directory to overlay as the same structure as exists in /usr, which KDE-builder does actually create such a directory inside the directory ~kd/usr by default. Okay, prepend /local/bin into z-rc, which we didn't do yet. Or how do we do that? ~/local/bin is not added, and that's a bug. Even if the directory does not exist, this, even if ~/.local/bin directory does not exist, this directory should be first in the search path, in the environment variable path. So we need to do these things. Okay, probably it's okay if we just start a new shell. Echo $path. And ~/.local/bin is the first directory. ~/ where we're in the wrong directory. Okay, but we did specify the correct path. KDE Linux defaults. Wow, what is that? Okay, and then we have this script. Let's see what this thing is. It's in /bin. kwrite. There's no such thing. org.kde.kwrite, because kwrite is installed from FlatHub as a flatpak package. Very empty. Why is that? This thing. So it's something about KDE builder. There's a configuration file, kd-builder.yaml. It's going to install KDE builder if it's not installed. It's doing the same steps that we did before. Download a initial_setup.sh file from the KDE Git repository of KDE builder, and it's running that file. And then the configuration file it's copying it from /usr/share/factory/etc. And then that's it. Okay, probably this configuration file is magical. Let's see if we can see it. Let's see what it does. Plenty of configurations. So it uses ~/KDE directory by default, these are the default settings. But this is not a default setting. It says include dependencies false, means that all of the KDE frameworks are shipped by KDE Linux as inside /usr, so there's no need to build any of the KDE frameworks, which means that if your application doesn't use any other libraries except for the KDE frameworks and Qt and other libraries from the KDE community, you can just build the graphical user interface application. In this case, FileLite, we saw from the flatpak manifest that it doesn't depend on anything extra except KDE libraries and KDE frameworks and Qt modules. And here is the interesting things. Although so install directory is not ~/KDE/usr, but instead it's /usr directory. Yeah, but we're not. So kde-builder builds git clones KDE repositories in ~/KDE/src, does code generation, cmake, configure step, builds everything inside ~/KDE/build, installs everything inside the ~/KDE/usr, but because we're not using our path, whatever, the binary files, the ELF files, think that everything comes from /usr, not from ~/KDE/usr. And at the final moment, we overlay ~/KDE/usr on top of /usr using systemd-sysext. Rel with Debian for the default build configuration. We'll use all of the vCPUs of this virtual machine. And the rest are just the defaults. Step on failure is true. Directory layout true. Flat. Okay. Just defaults in here. Ignore projects. Okay. Yeah. So there has been effort made such that KDE-builder works correctly out of the box in KDE Linux. But if you're following the procedure from KDE Linux, you're not following the procedure from kde.org and then how to start programming for KDE. Okay, let's run the script. Password for administrator for I'm not sure what. The sysext is named KDE, merged on top of /usr, which the directory is ~/KDE/usr, of course. When you put new files in ~/KDE/usr, you need to remember to run this command line. Sudo, because we're overlaying on top of /usr, systemd-sysext, which is the subsystem of systemd, and then the command line parameter refresh. Okay, hopefully this URL works. KDE Linux, add or overwrite content in /usr. /usr is read-only. We're using system extensions. We did that. Let's see what it says. Okay, we have the correct file, configuration file for KDE Builder. KDE Builder was git cloned and installed. Okay, let's see what it says. In order to use, we'll use the tool KDE Builder, and then we're running the command to refresh. This command line is just if you're building Plasma PA probably, which is part of Plasma, the pulse audio, the audio part of Plasma. Okay, let's see that command line. Says verify that it got enabled systemd-sysext. I'm not the super user. Says that indeed there is just one overlay that systemd-sysext knows about, which is /us on top of /usr, and extension name is KD. Okay, we're creating a file in top level in /usr named foo, which is just a plain text file, not an executable. And we make sure that it doesn't exist. So ls/usr. There's no foo in here. Now we re-overlay. And now there's a /usr/foo file, this guy. Okay, and when we're done, we can remove the overlay. Sudo systemd-sysext space unmerge. Okay, so let's actually build something. KDE-builder. For some reason, it's not on the path. Why not? ~/docker/bin ls, this directory. There's KDE builder in there. I'm not sure why. Code completion doesn't work. Okay, let's build something simple, such as kcalc, the calculator. Let's make sure it's not installed by default. Letter K, no, letter C. So kcalc is installed from a nightly flatpak. Okay, let's build something else. It's in here. What can we build? Let's build Kate. Okay, so this is when you go KDE builder with no include dependencies. It just builds the module that you gave it as parameter, in this case Kate. So KDE builder managed to git clone sysadmin repo metadata into ~/.local/state and managed to git clone inside ~/kd/src/kate, the git repository of Kate. Managed to run cmake configure in ~/kd/build/kate. successfully. All of the dependencies were there. All of the mandatory dependencies, maybe not all of the optional ones. And now it's running Ninja to build everything. The executable should be in here, in tilde/kd/build/kate/bin. Okay, so the compiling Ninja step finished successfully. The file was created, tilde/kd/build/kate/bin/kate, this guy. And then the equivalent of make install, so Ninja install has been run as the last step for this module, which happens in tilde/kd/usr/bin kate. Okay. And now we want to overlay tilde/kd/usr on top of /usr such that a new executable starts existing in /usr/bin, which is called kate. ls, how do we do that? /usr bin kate. Okay, there's no kate in there. It will be whenever we just run this command line. So here it is, kate. We also installed kwrite, so now we have two versions of kwrite, the one that's installed by default in KDE Linux, which is the KDE Nightly Flatpak, and now I have installed one using KDE Builder because kwrite is actually part of the kate KDE Git repository. It's just a kwrite is a kate with less plugins configured, which means less items in the main menu, less main toolbar buttons, less sidebars, less bottom tool windows, etc. Okay, so let's run kate, make sure it's in the start menu, development kate, this it is. Okay, let's see if we can inspect it with gamma ray because we're using the same Qt version, both for applications built using KDE Builder, because we're not building using KDE Builder Qt. We're not even building the KDE frameworks using KDE Builder. We just did build kate. So development gamma ray, and probably this is the one. Out of process, Qt 6.10 attached default values, and it complains that Yama is protecting ptrace. So let's see how we fix that. This is an unexpected surprise to have gamma ray installed out of the box, but to not have the Yama protection disabled. And we're not using Ubuntu. You can temporarily disable this restriction. Let's actually do it. Okay. Let's reopen gamma ray. Attach to kate. And this time it did work. Okay, let's inspect our way around. So widgets, because kate is a KDE widgets, a Qt widgets application, it's actually using KXML GUI, so the most KDE graphical user interface applications that use Qt widgets will have a similar structure of the main menus. We'll have a main toolbar, a similar possibility of editing the main toolbar like this, a similar configuration for the main toolbar like this, if it works. Not sure why it doesn't work. It doesn't work because it's... Oh, it should. Okay, including this main menu item, help, and then handbook F1. Which in this case does the wrong thing. It opens a URL instead of using the locally built K-help center, which I'm not sure why it does that. It's a bug. So KDE Linux, kde-builder gate should use handbook from /usr. Okay. So we're in the widgets tab in Gamma Ray. We can select the window if there's multiple ones, but there's just one. Let's zoom the thing to 50%. Let's pick a button and inspect it. The button new file. Okay, let's look at the stack of Qt widgets parents. So there's a Q push button that has a text, this guy, new file. Let's change it. New text file. And it worked. And if we press the Alt key, it will show the accelerator, which is an underline under the first letter, the uppercase N. And it works. And we can make it larger, etc. So a runtime inspector of KDE Qt applications that can read some of the properties of the objects in the live running application, and it can actually set some properties. So read most and write some of the properties. I'm not sure if I can delete. That would be interesting to delete objects. Okay. Save as image. There's all sorts of other inspectors in here. The Zen kernel from Arch Linux. Qt project. Okay, so .theme files are actually source code files. As Qt resources inside executables and other ELF files, such as .so files, you can have plain text files like these ones, binaries like this one, but also images, PNG files, etc. Scan for problems. Multiple connections to slot. Okay, and that's it. Probably the workflow that seems to be the workflow that seems most logical here is to, I don't even know. So kde-builder will by default build all of the dependencies of a module, such as Kate in this case. So that means it will build around, I don't know, 70 KDE Git repositories until actually getting to build the repository that you want, which is Kate. But KDE Linux, the operating system, can allow you to skip building all of those dependencies, all of the 70 Git repositories that you don't really work on. But in the case that you're working just on Kate, not on the other KDE frameworks, KIO, etc., that are actually used by Kate. So in this case, you could have a workflow like every morning, download the latest, or not every morning, wherever you want to fetch newer KDE frameworks because reasons. You're downloading the latest KDE Linux raw image, you're creating a virtual machine, make it as beefy as possible. In there, enable KDE Builder, running these steps, 1, 2, and then you're going to have the possibility of building Kate really fast. I'm not sure why you would do that, because in this scenario, you're not actually using your hardware computer, you're using an intermediate virtual machine. And that means that building will be slower. And then how do you expose your home directory to the virtual machine? I don't know. So maybe that's not the intended use. Maybe the use is to just install KDE Linux on your hardware machine, on a beefy one, where you're actually doing everything KDE related, where you have your online accounts, where you set up KDE Builder, and then from time to time you update KDE Linux. Maybe you don't update it daily, maybe you update it just once per week to not do so much network traffic, download 6 gigabytes daily. But then you have other limitations, like I'm not exactly sure how you're going to be able to use inside this setup the tools that you usually use on a normal Linux operating system that's not immutable. How do you install Qt Creator? How do you install Visual Studio Code? I know Visual Studio Code, you can install it from Snap Store. But how you install the rest of things? Like, I know, CPP check or CLazy, crazy. Who knows what other things you need? OBS Studio, you can fetch that from Flatpak probably. FlatHub. Yeah, if you can survive in an immutable operating system, then yes, you can install KDE Linux on a hardware computer and actually do development. Maybe if you have, for instance, a laptop that's dedicated just for KDE development and other open source contributions. And then you know all of the tricks to have inside there the software that you actually need and the containers that you need and exposing graphical user interface applications from containers and network mapping, etc. So this was it. This was about this wiki page, how to develop software for the KDE community on top of the Linux operating system KDE Linux, the operating system from the KDE community. There's 3 possibilities: sysext, and then there's KDE Builder in there, or flatpaks with flatpak builder, or distrobox, and then you put KDE Builder in there. This is it. Thank you.